Okay, let's start. First of all, I'm sorry, I still have like a cough. I hope the sound guys are not killing me for that. And I'm sorry that the title is screaming at you in all caps. That's our corporate design. What can you do? So I'm Max Bureck. I'm from Fraunhofer Focus. And it's a huge institute in Berlin. We're doing lots of stuff since we're engineering a connected world, right? That's a lot of work. And the division that I'm on, we are doing mostly like model-driven software engineering, model-driven testing, but yeah, engineering, model-to-model transformation, model-to-text transformation. We have a product called Model Bus that's something like a model-based continuous integration. So if you, for example, use Papyrus and another division of your is using EA and you enterprise architect and you want to like collaborate, then you might ask us because we have the solution for that. All right, but that's enough about that because I'm not really talking about much model-driven stuff today, but like more general purpose patterns in the language that you can use. So who of you has never seen any Xtend code? All right, this might be difficult to follow, but maybe you can still like get something from that, right? At least some jokes. So it is a general purpose language that transpiles to Java code. So in the end, you can get Java code, and you can even later on work with Java code if you want to. The syntax of Xtend is very flexible. So you can define like internal DSLs, like you can use language features itself to define APIs that look like DSLs. And this presentation doesn't explain the all of the language features, so sorry guys. But it will show you like some ways how to use these language features, hopefully for a benefit. So the patterns that I will show are based on some observations that I had, and internally we used Xtend for a very big model-to-model transformation project also. And some of the stuff is inspired by other languages like Scala and F#. And the patterns that I show here, some of them can also be automated with the feature called active annotations. I won't go much into that, but these are basically like a clean macro system that you can generate code during the compilation phase of Xtend. If you have more questions, there's Sven Eftinger, right? So I can point to him if you want more insight into that. But yeah, so some of the things that I show can even be automated, and things can happen behind the scene without you having to implement lots of stuff. Okay, so here's the list of pattern. No, this is a list of things that Xtend gives you. So for the guys who don't know Xtend, here are some like hints what the language features are that we can use to implement our patterns. So first of all, we have lambdas, and if we call a lambda, so lambda looks like this, right? It has the square brackets, and you have the parameters and this pipe symbol, and afterwards like the code of the pattern. And we pass the lambda to a function here. And first of all, if a lambda is the last parameter, you can pull it out behind the round brackets. And if you have one parameter, you can even omit the round brackets. So it looks like this. And if you wrap it around the here, it kind of looks like a block, like a named block, right? So we will use that. So the next thing is that if you have a setter that doesn't return anything, so unfortunately this doesn't really work with the like Fluent style APIs. You can write it as an assignment. So this assignment will then be transpiled to the Java code of calling a setter. The next thing is extension methods. If you have methods in your own a compilation unit, or you import them with the word extension. So you have a static import of a function, and you add the extension keyword to it. Then you can pull the first argument out and call first argument dot something on that. And that can be used to enrich existing types with methods that were not on them before, right? So if you know C# and extension methods, that's something like that. The next thing is operator overloading. So for a fixed set of operators, there are, if you use a certain name for a function, you can simply use the operator for that. And for example, there are literals for big decimal in Xtend, and the operator plus is already defined for you. So you can use big decimals as literals and use operators right away in Xtend. Active annotations I won't show, but as I said, you can use that to automate some patterns. Okay, so here are the patterns and some patterns that don't show. I started with a presentation that's like 2 hours long and cut down to like 35 minutes. So maybe I release some of them as like YouTube videos of like further patterns that I find interesting. So nested block syntax, Fluent case distinction, like patterns for immutable data structures. Then, interestingly, you can do something like implicit parameter values that you know from Scala, maybe. Like with some magic, you can do that, but it's also hard to understand, so I didn't include it. Type providers is basically just a special case for active annotations, and API extendification, so enriching APIs using Xtend. Okay, first nested block syntax. Let's start on the next slide with the Java example. So as I said, like if you have the Lambda as a last parameter, you can write it behind the function call, and it looks like a named block, basically. And this is extremely nice if you want to have a more declarative look for something. For example, if you build UI elements or you have some configuration, like nested configuration and so on, right? So let's start with a Java example. That's a bit unfair because like the API here is tuned to look nice in Xtend. But anyway, this is an API that always gives like a callback into a function. And then operates on the parameter that's given to the function, right? And it's a silly example of an API for like a server, and it's using like stringly typed APIs here, where you have like a string reference and use it later on. Let me already point to a presentation on EclipseCon Europe from last year. It's on YouTube. It's a very good, also for the guys who don't know Xtend, right? Definitely have a look at this presentation. It shows how active annotations can be used to get rid of like the stringly typed APIs. But let's have a look how the Xtend version of this code looks like. And I think it's way cleaner, right? But what features of the language did we use to create the simple version of this API? So the first thing that we do is that we have a function, right? And we pass a lambda to it. And oh, I didn't mention that earlier, although it was on the slide. If you have just one parameter and you omit it in the declaration, then there is a default one that's called it. And you can, if you access like fields or methods on it, you can do the same thing as with self. You just omit it. So what this does is it's calling set port with 80 on the parameter that was passed into the lambda here, right? And yeah, the next thing is we again like call a method and pass a lambda. And here is the mapping over operator that is already coming with the language. And another interesting thing is here, it's an extension method. Let me go back to the Java code. So we're calling a static method here from the class HTML builder. We pass in a response and a lambda. And what we do is we call an extension method on response now. So here, what HTML does, and it is the editor will mark it red, so you see this extension method. It's not really a method on the type, but it's an extension method. So you now call response.html, but it's an extension method. This is the method in another class that is called, and this allows you to like tear apart the HTML method here. It doesn't have to do anything with the server. The server doesn't know about HTML, but there's another HTML builder that is responsible for that. And in the end, we returned something that because the last expression that's evaluated the result of that will be the return value of the method. So this kind of looks declarative and nested. Of course, you have to take care if you nest something like and nest it very deep. At some point, you're in the pyramid of doom, right? That you know from callback code from stuff like Node.js or maybe Vertex. So at some point, if you're deep, you may think about like componentizing some of the parts. So these nested blocks, they kind of reflect like logical containment structures in code. And it can reduce visual noise and looks kind of declarative. And you don't do stuff one after another. Like you create an object and then you set something on the object, but you like really nest things in the way that they're used. And it can improve maintainability because like what you see here can be more clear than this version, I think. So next is Fluent case distinction. First we start again with a bigger Java example. It's actually not that complicated. We have like a person and we get the parental status of that person, and this has subtypes. So it can be the parental status can be a parents or orphan or something else. And first we check for the parents, and then we cast to parent, and then we get mom and dad out, and these are optional, so they can be there or not. So we have to do some shenanigans to find out if both are there, and then print out the fields, the name fields. And orphan, again, we have to then cast to orphan, and so on and so on. And first of all, it's a bad signal-to-noise ratio what we have here. So we've written a lot of things, and actually we just decomposing objects. And Xtend already has this a very powerful switch statement. If you don't know it, have a look at it. You can like switch by type, for example, like no instance of and casting shenanigans. But it still lacks decomposition, as you may know from pattern matching from more functional languages like Scala or nowadays even JavaScript has decomposition. Here's an example of a language called Rust. That's a more low-level language for with actual high-level features from Mozilla. If you think about doing something in C or C++ for performance reasons, have a look at Rust. But it's not a talk about Rust. I just wanted to show you some like decomposition in pattern matching, where it's the exact same example, but we say, okay, we decompose parents, and if they have mom and dad, like some types, like the optional has two versions, like either none or some. and we have sum here, and we have mother and father, and then we print them. If we have an orphan, we get out the orphanage name, and we print out the orphanage, and otherwise we say parental status is unknown. But all the examples like lack the case where it's just one mom or dad, but we just don't ignore that, right? That's also why we have to have this like wildcard here and say, okay, and because like the compiler of Rust says, there are cases you didn't like cover. Yeah. Anyway, but in Xtend we can cleverly hide some of the boilerplate and create something that I call Fluent case distinction. So instead of having subclasses, or you could have subclasses under the covers, you return an object that does the decomposition for you. So there's parental status returns an object, or yeah, an object that has like case functions on them. You pass methods, you pass lambdas to them, and if there is a decomposition for case parents, then the lambda will be called. Otherwise, the case function returns another object or the same object, depending on like how you optimize it and like what you want to do. That again you can call a method on them, and this kind of looks like a switch case, and you don't even have to look up like subclasses, for example. Like you don't have to look. Okay, there is a parental status returned. Let me look up all the subclasses that are possible. But you can like explore the cases by just saying dot, and you get the cases, right? You get the decompositions. Of course, as this pug is not Yoda, although he kind of looks like Yoda, this is not like the stuff that I've shown is like just hiding some boilerplate. It's not like actual decomposition and not as flexible as the the object decomposition that you get from Rust or Scala or something. But anyway, you can define like object decomposition in cases that kind of looks like a switch case with the object decomposition, which I think is kind of nice. Yeah, as I said, like oftentimes like the switch statement is good enough, but it's still interesting if you, for example, want to have a short notation for reoccurring complex decomposition of objects. Or like some fields are null and some are not null, and you want to distinguish between cases where like these fields are null or that fields are null, then this is kind of nice. Depending on how you shape the API, sometimes you can even enforce at least having a default case in these switches. And as I said, like this can be an alternative to having like object hierarchies. You can just have the cases, and you don't make the user look up like all the subclasses of a class and cast to that classes. All right, immutable data structures. So I'm not giving too much time into like saying why immutable data structures are good to use. Like there are some use cases. Sometimes they're not good to use. Like Brian Gutz says, these are good for the can be good for the garbage collection. Like some other guys, like Twitter JVM guys, say, okay, there are horrible cases for garbage collection. And of course, they produce more objects anyway. But they have their upsides. If you pass it on to these objects on to another method, you're sure that no one there will modify it. And therefore, it's also good for multi-threading because you can safely share them between threads, right? OK, so but they're a bit tricky. And especially like object manipulation, and yes, I come back to that. They're immutable, so you can't like manipulate the object itself. And circular references, which I will just like briefly cover. Okay, so one pattern is for instantiation. One pattern is to use a mutable builder. because you maybe want to set like a field twice. You want to like do mutable like imperative stuff, and afterwards like create the objects. And there's a nice pattern for that where you have a create method. We pass in a lambda, and the lambda has a first parameter that's not shown here. It's the mutable builder on which you can call the setters. And the create method will call the lambda with the mutable builder, and afterwards call build on the builder. So this kind of looks like named parameters, kind of, right? And the nice thing is in here you can do like impure stuff and reassign something twice, and afterwards you have like the immutable object in your hand. So again, like the setters can't have return values, so you can't mix this with like Fluent style APIs. Anyway, it is a nice pattern, and you already, if you think about it, you already think, okay, maybe circular references are tricky because you have the object, the chicken egg problem. Like if they reference each other, how do I create them both knowing about each other? It is possible doing some lazy stuff with the lambdas, but it's tricky. All right. Another downside, of course, is that the compiler cannot check that if you pass all mandatory fields, right? With parameters, if you don't pass in one parameter, the compiler says, hey, there's missing something. But here, it's a runtime error. That's a problem. So the thing about object manipulation is that every time you want to manipulate an object, you create a new object that is manipulated in the way you want it. Do you know the Java 8 time API, the new date and time API? They have the with methods, right? So you have an object and you say with, I don't know, time something, and it returns a new object for you where the field is updated to the new value. I will show you a slightly different approach, and I will show you why this is nice. I call them update methods, and the update methods, instead of giving a new value for a field in, you pass in a lambda that's mapping from the old value to the new value. I will show you an example in a minute, so maybe it's more clear then. So here's an immutable person. It's not immutable in the sense that you can't stop him from talking because he's not mutable. It's a not changeable person, right? And here we have update methods for first name. And what it does is it takes a lambda from string to string and from old first name to new first name. It applies the method and creates a new version of immutable person. So here you see the usage and why it is can be nice to have to use these update methods instead of the with methods. So first of all, you can just call it like this, and it kind of looks like a setter. You pass in a lambda that just returns a value, or you can have you can update the existing name by just calling a method on them. So this is it.toFirstUpper. So it returns a person with a new first name that's the old first name with the first letter uppercased. And the nice thing is that you can nest this. So if the field is again an object with update methods, you can have in there, you can call another update method. So you can go in an object hierarchy and have like these nested callbacks and update something like way down the hierarchy and update all the objects down the hierarchy, like up the hierarchy. So you get a new root with all the down the hierarchy objects changed. All right, one more warning about cyclic references, because cyclic references are like a pain in the rear end. if you want to do manipulation like this nested style. If you think about generating like these update methods and think, okay, how do I allow cyclic references? It gets really hairy. So if you think about it a different way, maybe. Next thing is that you can also update in a different way. We can, for example, I'll show you the example. You create, like with the Lambda builder pattern that I showed you already, and now we have a with method. The with method gives you you pass a Lambda to the with method. It gives as the it first parameter an already pre-filled builder with the old field values. Now you can again like use the builder, and in the end it will create an updated version of it. And this is something that looks like an F# with method or with function, where you update an existing object. And the nice thing about this is that you can like update many fields. And again, it looks like named parameters. So it's kind of a nice pattern and looks kind of declarative. And now you updated Homer Simpson to max power. Okay, API extendification. So as I said, of course, like Java APIs are not written in a way that they can be used nicely with Xtend, right? And only like some features of Xtend only shine when the APIs are shaped in a certain way. For example, if the Lambda is the last parameter, you can write it behind the function and wrap around. Anyway, the last parameter should be the Lambda, because otherwise you have like the parameter list and then like something wrapping around and then something in the end that you don't see anymore. The JavaScript land learned that pretty fast, but there are some Java APIs that have like the callback object is not the last object, where I think the last parameter. I think like, why do you do that? But I won't show this example. I will show some different example of something that you should now be already familiar with. But like first, the thing that you want to do to augment the Java APIs to look nice to use with Xtend and use like the nice features of Xtend is extension methods, right? So you augment types with functions that were not there before. So extension methods to the rescue. All right. So here's an example from the JDK. And we have the thread pool executor, and it can take some parameters, and you don't write the parameter values in there because you don't know what they mean later on. So you like pull them out to like variables or to values, to immutable variables before you call the constructor. And yeah, the problem here is that I accidentally switched the maximum pool size and the core pool size. So it didn't help that much that I pulled out the parameters. And the compiler doesn't complain because both are int types, right? And you may know the answer already. The answer is having a builder, because in the builder you have kind of named parameters. So let's create something here. We create a method where we first pass in the class of thread pool executor. And you may ask, why do you pass in the class object of thread pool executor? You don't even use it later on. Why? I will show you in a minute. First, like the sausage of this Lambda builder method, we create a mutable builder. As I said, the Lambda, the config Lambda, I call it and then call it build. And now I show you, maybe now it's clear why I passed in the class object. Because in Xtend, you can reference the class object of a class by just writing down its name. You don't have to write .class. It's just a name, right? So if I use the method as an extension method, instead of passing the class as a first parameter, I write class dot, and it will pass as the first parameter. And now we have an extension method that looks like a static method call, right? So we emulated a static method call in Xtend by using extension method on the class object. And now you should be familiar with it because I presented the pattern earlier. It's the Lambda builder pattern, where you have a Lambda that gets a builder. And now there is no way in hell I can assign the wrong core pool size, because like I'm now referencing the actual method core pool size and not like have it as a parameter, and I have to like stick to the order of parameters. It's kind of a named parameter now. Okay, so I may have referenced this already, like the 10 Java idioms stumped by Xtend talk. It's a really great talk from last EclipseCon. Have a look at it. Also shows some other features that I didn't. I will also publish the slides with the links, of course, so you can then just click them. And just some like brief summary. Like Xtend as a language is pretty flexible. Like the feature set that it has, you can like really exploit to do interesting stuff. I will not hide that if you overdo it, you sometimes don't understand your code anymore. So like it's a Spider-Man language. With great power comes great responsibility, right? But other languages are worse, I think. Like Scala can be worse. Like after a short time, if you go crazy, you don't understand your code anymore. If you do it right, you can have declarative-looking DSLs that like clearly show the intent and like remove lots of cruft that you used from Java code, and you really see like the business logic and not like conventions that you need in the language. And it enables, since you can leave away some things, right? It enables new ways to define your APIs. Like with the nested blocks or the Lambda builder patterns, the immutable stuff. You can all do that with Java, but it doesn't look that clear when you define APIs in that way. And you have patterns to make Java APIs even look nicer to use in Xtend. And as I said, like some of the patterns that I've shown, you can define own active annotations. So basically macros that you can generate code. Like builders are easy to generate, right? So why not do that? Okay, because I always forget this slide. I put it a little bit earlier, so vote. And I'm very interested in feedback if this was useful, if I was just confusing, or this was just too obvious that or you have maybe a different pattern that you really like. I'm interested in that. And the last thing are like where I got the images from that I didn't make myself. And this is how you can reach me. Thank you very much. So how am I?